Hello, everyone. We are back for Advent of Code, Day 12. Advent of Code is a 12-day coding challenge. Um, Not a 12-day coding challenge, a 25-day coding challenge every year, every December, where, just like an Advent calendar, instead of getting little nuggets of chocolate or little knickknacks, you get little brain teasers. So let's get into it. Today, we have Day 12, Rain Risk. Your fairy made decent progress towards. So, just to give a little background on the lore, normally, most years, we're saving Christmas. We're not doing that this year, it seems like. We're trying to go on vacation. And I think we all deserve that. It's been a rough year. So, we turn up the music a little bit more. So, we have so far committed numerous felonies on our way to vacation. Initially, we faked our passport. We faked a boarding pass. We hacked a young child's game console and bypassed its copy protection. We've hacked into the little outlet in front of our seat, and we figured out the best place to sit after we land, I think. Okay, so now we're on to day 12, and let's see what happens now. Your ferry has made decent progress towards the island, but the storm came in faster than anyone expected. The ferry needs to take evasive actions. Bold. Unfortunately, the ship's navigation computer seems to be malfunctioning. Rather than giving a route directly to safety, it produced extremely circuit. Okay, I'm gonna need Google's help here. How do I? I've never seen that word before in my life.
Circuitous.
Circuitous. Circuitous. Okay, that makes sense. Okay, most circuitous directions, which I'm assuming it means it goes in a circle. Let's check actually. Longer than the most direct route. Okay, that makes sense. When the captain uses a PA system to ask if anyone can help, you quickly volunteer. So we're actually doing some good for a change. That's nice. We're not trying to ruin. We're not trying to flout any laws or be nefarious anyway. That's maybe we're in the lore. We're taking a turn and we're becoming good people. The navigation instructions consist of a sequence of single character actions paired with integer input values. After staring at them for several minutes, you work out what they probably mean. N means north, S south, east, E east, W west. L means turn a number of degrees. Okay, that makes sense. R means turn right a number of degrees. F means forward. The given value in the direction the ship is currently facing. Okay. The ship starts by facing east. Only L and R actions change the direction the ship is facing. That is, if the ship was facing east and the next instruction is north 10, the ship would move north 10 movements, but still move east if the following action were F. That's... what? What? So as a ship, we can be facing the east, but still travel north deliberately? What is this, like a helicopter ship? I don't understand. I don't understand. I have no nautical background, so maybe I should not be questioning this, but this just does not really seem correct. So the ship starts facing east. Glenn is coming up with the answer. Magic. I should have known that. The magic of Christmas. The ship starts facing east. Only L and R actions change the direction the ship is facing. Okay, that's just weird, but we're gonna roll with it, okay? These instructions would be handled in the following ways. We move east 10 units because we're starting off east. That's a given by the problem. N would move the ship 3 units north to east 10, north 3. Okay, that makes perfect sense. F7 would move us forward east. Yep, that makes sense. So we're now 17-3. R90 would cause the ship to turn right by 90 degrees and face south. It remains at east 17, north 3. Okay, that makes sense. I wonder if the rotations are ever going to be like weird, kind of like 13 degrees or something like that. That would be really awkward. Okay, F11 would move the ship 11 units south. No, I checked in my input. Okay, I'm glad they're not doing anything weird like that. That would be really cringe. 90, 80, 270. Those all seem like really straightforward. I don't know how I would do it otherwise, to be honest. At the end of these instructions, the ship's Manhattan distance. I don't actually know what a Manhattan distance is, but I guess we're going to Google that real quick. Some of the absolute values of its east-west position and the north-south position. Oh, okay, so maybe they just told me. From its starting position. So it's kind of like the vector from where you are. Oh, it's not the vector, though, because it's counting like blocks. Okay, so that's why it's called Manhattan distance. That makes sense. So it's kind of like the absolute value. So if you start at 0, 0, it's the absolute value of your offset from there. Because presumably we're going to count like north as being positive and south as being negative or something like that usually, right? Figure out where the navigation instructions lead. What is the Manhattan distance between the location and the ship's starting position? Okay, this all seems pretty straightforward. I need to think through a little bit like what each rotation really means in terms of changing direction. That's not free. But that's just thinking through it a little bit, so that's not too bad. Okay, so let's start off with our sample input. Let's make a new directory for this. Day 12. Copy over day 11. Problem 1 to here. And we're gonna make a sample file real quick based off of what they've given us so far. Close these down. We don't need those anymore. Sample is really, really true. I wonder if we're going to have a second sample for part 2. That sometimes happens when part 1 is like really, really excessively trivial. Okay, so let's get into problem 1 here. First off, we're going to do, before we do anything else, we're going to switch over to sample. And we're going to get rid of everything except for our input lines thing, because we don't need anything else, really. Okay, let's get rid of all. I'm failing at Vim key bindings. Help me. You'd think after like 20 years of doing Vim key bindings, I would actually just do everything correctly the first time, but no, that's complete lies. Okay, so we're gonna start off with our input lines, and let's just write out in comments. We're initially facing east, so let's make northeast positive. South and west are negative. Just as like a mental note from myself there. Okay, so input lines can actually just be used as is. We need to split out the command from the instruction though. So let's do a little map here. And it's really just the first character that's the command. I don't even know if it's like really this parsing is so trivial. I don't even think this is necessary. So I might end up getting rid of this anyway, but I'm just warming up here. I'm just what we need here. So we'll just turn this into arrays where I always forget, can strings be accessed with array notation in Ruby? Why do I always forget this? They can. Zero, then this should be 1 to -1. Yep. We don't actually need to hold on to these for any reason. Just do instruction value. It's a little clunky, but I'm not sure exactly what I'm going to throw into a sub method into a method quite yet. Let's say that initially our north-south is 0, our southeast is 0, and our rotation is 0. So we should also kind of like define what left and right is. So let's say that left, if we think about it in terms of like the unit circle, rotating left would be positive, while rotating right would be negative. Actually, let me, just thinking through this. We probably want to just like automatically, when you go negative, automatically add a 360 onto it. I gotta get a compass with north, south, east, west on it. Did I do something wrong? North, south, south, and east? Did I forget west somewhere? Oh, no, we're good. I have northeast and south and west. I have all the things we need here. Oh, and my variables. Did I screw that up? Oh, yeah. Okay. And actually, maybe for consistency, east, west, because east is positive. Yeah. I see what. Hey, naming is hard, but when we say that, we don't actually mean that. That's just clumsy of me. So I think left is positive, and right will be negative because of how we usually treat like the unit circle. Usually like east is like 0 degrees, while north is like 90, and so on and so forth as we go around the circle. Maybe it's useful to kind of like have a hash of what different rotations mean also. I think that's gonna... say that 0 means when you're at 0, we're going just east. So there's no change to north-south. And east-west would be positive. When you're at 90, I feel like there's probably a better way to represent this. Or am I does this need to be... Yeah, 180 would be the next increment. Yeah. That's -1, and we're just gonna like multiply this to determine which direction we're going, I think, or something like that. We're gonna do something like that. Uh, 270. Oops, there we go. I don't know if I like storing this as a hash like this, but we're running with it for now. Yeah, I think I like this representation. I'm kind of just kind of like thinking through real quick what this is going to look like. Okay, so we have this broken out instruction value. So, all right, let's just have like a bunch of ifs for each possible command, right? If f north south plus equals value times then rotations uh, rotation north to south. Get rid of this sidebar so we can a bit more. Ooh, we're on the brink of how many characters I want those lines to be for stream. And then east west is going to be. So we're going to take the scalar, and this is going to indicate like what direction we're going. We're just going to multiply the scalar that we're given for our f command, and multiply it like for north. If we're currently faced east, we are facing east, so our north-south direction is just going to be 0. And we're going to continue east-west positively because east is positive, right? So that'll give us valid offsets for where we are currently east, west, and north, south in comparison to where we were originally. Okay, so else if n, everything else is very trivial. Else if s north south minus equals value, because going south is generally a negative action in our lives. West plus equals value. West minus equals value. It's kind of ugly. And then we're gonna just, if it's none of these, let's just. Oh, I don't have the rotations yet. Also, okay. I was about to say let's raise an exception otherwise, but else if L rotation plus equals value, and we can actually clean up the rotation at the end. I want to do that for both of these. While rotation is less than 0, but we want to take away if it's going right. Rotation plus equals 360. I think that's here. While rotation greater than 360. Gonna minus. So we're gonna make sure that rotation is always within the bounds of 0 to 360. I don't think there's ever a case where like it's gonna be like 2 360s over, but we'll throw it into a while instead of an if, just to be on the safe side. Okay, so once we get through all of this tomfoolery, we should know where we're at. We should have some sort of value for where we're at. So Manhattan distance is the sum of the blocks as absolute values. So let me just double check. I think it's ABS. Yep, ABS. That's perfect. That's exactly what. So let's take north-south ABS plus east-west ABS. Distance? Actually storing in a variable, because I feel like we're going to need to do more with that with part 2. Okay, let's see if I have any like weird like syntax errors. That's always a very common theme here, right? Problem 01. String literal and condition. What's 34 here? What? Oh. I was treating this kind of like a case statement. Actually, we can just do this as case statements, really. Oh, and also I did want to else. I always hate using Ruby case statements, so I refuse to commit them to memory. How those syntax. Case when. It's actually kind of cool how they work because you can actually overload the. There's actually a case operator that you can overload to make different types behave differently for them. So like instead of like a C where it's like just like literal equals equals matching, you can like match on like regular expressions. You can actually match on classes to see if things are like a subclass of this and stuff like that. So they're kind of cool, but I don't know why. Case statements are cringe. You don't need to break like how you do in other languages. There's no automatic pass through. That's just terrible. Raise. And also, what's this other thing? String can't be coerced into. That's. Oh, you know what? I need to cast this second argument into integer each time. That totally makes sense. Clear this out, and we're going to run this again. 25, and that is the value we were looking for. Okay, cool. So let's grab our puzzle input and try it on there and see if things go equally well for us. I'm going to copy this over. Make sure we have the right file. Yep, this looks correct. Oh, we have so many things open. We don't need all these editors open. There, that's much nicer. So we also want to make sure that we're running input. Bring our real input and see what we come up with. What? We did something wrong here, that's for sure. Undefined method for nil class. Huh. I wonder what caused that. Let's print out each instruction as we go along and see where that went. Because it has to happen in our. Let me just check. 18. Okay, 18's our loop there. 55. That's just our main function. Let's print out each instruction and value. And see how far this gets along before it raises an exception. So it doesn't like F11. That's fascinating. Huh. Is F11 like the last one, maybe? Search for F11. Okay, there's a few F11s here. So it could be... Does it feel like we... Or I think we only got through like maybe 50. I don't think we got to the second. Yeah, that's like definitely the first one. So let's set a breakpoint when we hit F11. Oh, maybe we have a rotation that's not in our list. Or maybe I mistyped one of these keys. These keys all look right. It has to be a rotation that's not in our list. So actually, let's do this instead. Let's grep our input. Oh, do I remember the order of this? I don't know. Is it file or first or argument first? I don't remember. But we're going to find that out real quick. Okay. Let's print out our current rotation in addition to, okay? That sounds like a good idea. It has to be a bad rotation. It has to be a rotation we're not accounting for. $360. Oh, so it's exactly 360. So we want this to be greater than or equal to, because we're not going to account for 360 is the same as 0. That makes so much sense. Perfect. Okay. So I don't think we're going to run into any more problems. Fingers crossed. We don't need the mining pry right now. Let's just comment that out. Okay, so we have a value. 858. Let's see if that's correct. I mean, otherwise we're just going to be in timeout land for a little bit, but I think we're going to need that timeout to figure out what the heck went wrong anyway, if that's the case, right? Let's see. Okay, cool. We got for part 1. Now on to part 2. First things first, let's copy our file over before I start clobbering my results from problem 1. Okay. Before you can give the destination to the captain, you realize that the actual action meanings were printed on the back of the instructions the whole time. Almost all of the actions indicate how to move a waypoint, which is relative to the ship's position. N means to move the waypoint north by the given value. S, okay, so and so forth. Left, right, and F. That all... so basically we're doing everything to a waypoint instead of the ship itself. I don't know exactly what a waypoint is, but I'm sure we're going to figure it out real quick. The waypoint starts 10 units east and 1 unit north of the ship relative... 10 units east and 1 unit north relative to the ship. The waypoint is relative to the ship. That is, if the ship moves, the waypoint moves with it. Okay. In this example, using the same instructions as above, F10 moves the ship to the waypoint 10 times, a total of 100 units east and 10 units north. Okay, I'm just grokking this a little bit. So the ship always moves in the direction of the waypoint, and the waypoint moves along with the ship. So the waypoint is always... Is the waypoint always 10 units east and 1 unit north of the ship? Yes, because on this first line we're seeing here, the waypoint stays 10 units east and 1 unit north of the ship. I wonder if that changes with the rotation order. Okay. And moves the waypoint 3 units north to 100 units east and 4 units north of the ship. The ship remains... So the ship doesn't move at all unless if we're hitting F. Okay. Okay, this all makes a whole lot of sense so far. F7 moves the ship to the waypoint 7 times, leaving a total of 7 units east and 28 units north. So the waypoint is... So the north, south, east, west and rotation is always saying like where the waypoint is relative to the ship. So north 3 moves the waypoint 3 units north. So it goes from 10 units to 4 units. Okay, okay. I think I'm understanding what we need to do here. At least I'm understanding the problem statement. The waypoint is just kind of like giving a scalar that the waypoint's giving a vector that the ship has to travel X number of times every time an F command comes in. Waypoint stays okay. 90 degrees rotates the waypoint around the ship clockwise 90 degrees, moving it 4 units east. And okay, so where was it before? It was... Waypoint was 10 units east, 4 units north. Rotate 90. Rotates the waypoint around the ship clockwise 90 degrees, moving it to 4 units east and 10 units south of the ship. Okay. So it goes from 10 units east, 4 north, to 4 east, and units south. So if we have... Actually, can I get paint? I actually don't know how to use paint since they keep on redoing it. I used to like it when it was just like a very simple program, but now it's very complicated. What does my brush look like? Can I just draw? Okay, I can just draw. We have our ship here at... Let's just say that I'm just trying to kind of like figure out the waypoint math. So this is always 0, 0 because relative to the waypoint. Waypoint position 1 is 38 by 170. And then it rotates right 90 degrees, so it would end up in this quadrant. And that ends up looking like 10 and 4. Oh, the ship is at 70, 38. The waypoint's at 10 and 4. It's at 4 and 10, rather. And I guess if we're being consistent with our coordinates, we should use negatives there, right? Okay, so we're keeping the 4 units east, and we're minus 10. So I wonder if we can take our initial thing, our initial multiplier thing that we had, and just multiply the direction by those units. Or if we need to do some sort of like a trigonometric functions here. I know for a unit circle, the trigonometric functions turn into like basic +1 -1 stuff anyway. I think we're gonna just try it doing like the multiplication, and we might end up with really, really bad numbers, and hopefully we don't though. I think that might be okay though, just judging from the example. Because otherwise, what are we talking about? If we were like getting into the trig of it, it would be like something dumb like, how can I draw a line? Ugh. I'm so bad at paint. This triangle versus triangle here. Oh god, that's not what I wanted. That's fine, you get the idea. What I'm trying to do here. Ugh. So this angle right here would be something like cosine opposite, inverse cosine opposite adjacent, something like that. I don't know. I haven't used trig in a while. SOHDAHTO. I don't actually know what that acronym is. That's a new acronym for me. Either way, I think that maybe I'm overcomplicating this, so I'm just gonna try to do it with like the basic multiplication, because I don't think we need to do trig, because then we're gonna end up with like weird like partial numbers and stuff like that. We're gonna end up with non-integer math as well as soon as you dip into trig, I think. So I think that we can just do the multiplication and stuff like that, and fine. So how do I want to? Okay, so we didn't finish going through this. So F11 moves the ship forward another 11 times, so we have that vector set. Sine equals up. Yeah, okay, that makes sense. I know that I always remember that sine and cosine are over hypotenuse, but for a minute I was kind of forgetting what opposite and which one was opposite and which one was adjacent. And tangent's always obviously always opposite over adjacent. But yeah, I'm probably just overcomplicating it. Okay, so for the final step, we move by that vector again, and the offset stays the same. So let's move back into our sample input, because we're going to want to generate this 286 number. My high school math teacher taught the great Indian chief Tohokatoa. I think that's probably. I think your high school math teacher might have been a little offensive, although maybe an effective teacher. I don't know. That seems kind of that seems kind of sketchy, Glenn. Not to besmirch the memory of your old instructor, but that sounds a little. I don't know if I'm okay with that. The mnemonic is fine, but saying the great Indian chief part—that's the part that makes me go, okay, that doesn't necessarily sound great. uh, Whatever. That's how I remember it. No, that's totally fine. Like I said, possibly offensive, but definitely definitely like an impactful teacher, 100%. I think I kind of want a class to encapsulate like a coordinate. I feel like we're just gonna have like a million variables everywhere. So let's just like build like a little class here. Uh, does the ship doesn't even rotate anymore? Now that I'm thinking about it, maybe I don't need to track all that much stuff. Let's just try like hack this together a little bit, and maybe it'll be okay. So we definitely need to keep track of the ship northeast west and north southeast west, and now we need to track the waypoint. And the initial value, what was that? That was 10 and 1. The north-south is going to be 1. East-west, that's going to be 10. And rotation is still, we're going to say that it starts at 0. Do we need to track the rotation, though? Maybe we do. I think we do. Because we rotate it once to, what is our input, our sample input? We have the one rotation of 90. And that put us, but we multiplied north-south by -1. Oh, but we rotate it right. We rotate it right, so that puts us at 270. So north-south multiplying by -1 is actually appropriate there. I think this is good. I think this is okay. So we're going to handle these instructions a little bit each time. Let's get rid of this so we can actually see the whole body of what we're... Oh, there's our paint. I don't think we need that anymore. Okay, so we'll get back to F a little later. North, south, east, west becomes very easy because we're just moving the waypoint. Restoring the rotation, we're still calling that rotation because there's only one rotation we care about. We're not rotating the ship anymore. Who rotates a ship? That's madness. Don't do that. Why rotate a ship when you can rotate a waypoint? Okay, so rotation, we'll track the value, and every time a rotation happens, instead of having it be like 0 and 1, let's have it be... Oh, I think this is wrong. Because we're not going to be able to multiply by 0 ever. That's not something we're ever going to do. So this, I think the hash idea kind of works, but it needs to be adjusted. So there are different quadrants, right? Um, top right, positive, positive. Top left, I think we're assuming east west is x, north to south is y. Normal math terms, right? Top left would be negative, positive. Bottom left is negative, negative. And bottom right is positive, negative. So I think that's how these rotate. What's like the consistent way of multiplying where you're from and where you're going? So I mean, if you're moving from one quadrant to the other, we can just kind of like figure out like what quadrant they're currently in and force the positive and negative in that way. I feel like I'm still making this too complicated, but that's fine. So what's the transition here? What if we just like have it like we codify that part at least. Positive, positive. 90 is top left. So that's negative, positive. Oh, and I actually have these flipped because yeah. Let's reorient these, I guess. South. Up left. We can just be like, hey, if look at what you had before. Look at the cardinality of your old direction and your new direction, and if it changes, we're going to multiply by a negative 1. We're going to flip your sign. I think this is good. This doesn't sound like this should work, but so for our third thing, we have negative, negative. We have positive, negative, rather. Yeah. We're actually just going to stick these. Let's uh, we're going to try this up so that we don't have this while loop down here. Current rotation, current direction, and angle. Okay. Direction. Full. Just making sure we don't overflow here. Doing this because we're adding some more logic, I think, into L and R here. That. Okay, so we're gonna end up on top with. The part that I'm just kind of like getting lost on here is that I feel like, let's say that you start off 10 east, 1 north, and then you move 20 to the west, you end up at a different rotation, right? The actual. I guess we ignore that for now, but this just doesn't really make sense to me. Maybe I did the initial rotation wrong also. Maybe we trust that the thing never moves so far that it moves its quadrant, I guess. It never moves in an absolute direction that changes the quadrant, maybe? I don't know. Anyway, so we have the old rotation, we have the new rotation. So if we have our rotations, I'm trying to think of ways that we can make this also not like very repetitive, but I think that's what's happening right now. We might move this out into a function that gets to be kind of like Wonkadoo. Okay, so we have our rotation. So if our coordinates change, if the quadrant we're in changes, we're gonna multiply by 1 to flip it around. Copy paste not working for me. Rotations. Old rotation. Not equal. West. We'll flip your polarity in that case. It's not else, this is actually an option that can just happen. South, we'll do the same thing with north to south. And once we do that, I think that's all we need to do. This, because we're just changing the rotation. Doesn't feel right, but we're running with it. Okay, so F is going to be very different. The F part's very straightforward. Assuming that we have correct coordinates for our waypoint. We're just gonna we're just gonna move in that direction value times. The number of value doesn't really matter because what we're actually changing by is where our waypoint is. West, waypoint, west. This part I'm not concerned about. We're already back on sample input. I think we've made all the changes we're supposed to, assuming I understood. My big thing here is I don't know if I've understood the problem correctly. I feel pretty confident that if I understand the problem correctly, it's not hard. But I don't know if I actually understand the problem correctly, which is kind of unfortunate. So let's run this and see if we end up define north and south. Okay, we probably just did the wrong thing right here. This is on 96. No, that's 77. Oh, right. We had to adjust our variables at the very end. 286. Okay, so we seem to have done the sample correctly. So even though I'm still not sure if we actually did the actual problem correctly, let's see how it works on our actual input. 12,142. Okay. I'm nervous. We might end up in shame here and have to time out for a bit, but sometimes you just gotta look destiny in the face and say, we're going to hit the submit button, and we don't care what happens, right? We're just gonna do it. That's not the right answer. The answer is too high. Oh no. Make sure you're using there's some general about page. Okay, we went too high. We flew too close to the sun. So I think that we misunderstood something here. So let's read through this again. Or you can give the destination to the captain. You realize that the actual action were printed on the back of the instructions the whole time. Almost all of the actions indicate how to move a waypoint, which is relative to the ship's position. North means move north, south means south, east means east, west means west. Right. Left means to rotate the waypoint around the ship left, counterclockwise the given number of degrees. Right means to rotate the waypoint around the ship right, a given number of degrees. F means to just move forward to the waypoint a number of times equal to value. It starts at, let me just make sure, start at 10.1. That still looks correct. The waypoint moves along with us. So I feel confident that our F action works correctly. I think it's our R action that screwed up, which makes sense because I wasn't really sure how that should be implemented. F10 moves the ship to the waypoint 10 times. That makes sense. N moves the waypoint 3 units north, so it's 10 units east and 4 units north. The ship remains 100 north 10. That makes sense. Where was I? Sorry, I got distracted by another window there. Let me know if you want any nudges. I might in a little bit. This is really baffling to me. F7 moves the ship 2.7 times. That part makes sense, leaving the ship at east 170, north 38. Waypoint stays 10 units east, 4 units north of the ship. That makes sense. R90 rotates the waypoint around the ship clockwise 90 degrees, moving it 4 units east and 10 units south of the ship. The ship remains at east 170, north 38. Glenn, here's like just like one nudge I want, because I don't think I'm understanding the problem statement correctly. When we have north, south, east, west, does that implicitly change our rotation? Because I don't see how that possibly cannot. I'm not accounting for that right now. Because I think what I can do is I can calculate which quadrant I'm in and then do the multiplication that way. That's kind of where I'm leaning right now. Because if you start like northeast and then you move so far you end up in the west, that obviously changes your angle. North to south, east, west changes the location of the waypoint. Correct. LR also changed the location of the... Okay, yeah, okay, that makes sense. That makes sense. F changes the location of the ship using the waypoint's... Okay, that part I understand. The waypoint's location relative to the ship remains unchanged. Yeah, that part I get. That part I get. I think the only part where I'm screwing up is the R, the L and R, the rotation part. The direction that the ship is facing is not part of the problem scenario. Yeah, totally. Totally, I get that as well. So the fact that L and R can change the location of the waypoint is significant. So I wonder if I'm like just assuming that simple like times multiplication gets us there because that's what happened in the example. But let's roll with that a little bit longer before we break out any trig. Okay. Okay, so R90 in the example. Notice how they don't talk about the exact location of the waypoint. Yeah, the location's always relative to the ship. Yeah, no, I totally get that it's relative to the ship. That's why I'm keeping waypoint east-west as separate things, and it's starting off as relative to the ship. Okay, so I think what I'm going to do is I'm going to try to detect where the waypoint is in relation to the ship, to determine like its the polarity of its northwest. Oh, they swap location. Oh, did I not pick that up initially? Rotate more and okay. So starting at 410, you rotate 90, you end up with minus 10, 4. Okay, so I guess the part I missed was that the X and Y rotate as. Honestly, I don't know. I'm focusing on parenting stuff at the same time. That totally makes sense. Sure, sure, sure. That totally makes sense. Yeah. Yeah, the part I missed was the flip flopping between the minus 110 and the 10 minus the how how the scalar, not only the signs but the scalars are rotating as well. Okay. Just kind of thinking through how I'm going to make this work right now. 0 is B2. 90 becomes X. Like we said, for the polarities of so minus E negative negative. It's all really interesting. I have all these. So how do I codify this? Simple. I'm just being quiet because I'm trying to think through this. I'm not entirely sure how I want to codify this. So I'm swapping values when my before and after rotation is basically not like 180. If it's let's do this here. Full rotation minus rotation. 180, because we're basically assuming that we're doing things that divide evenly by 90. So the two cases are when it's like something that's dividable by 90 or by 180. Okay, so when we have this scenario, when you have this scenario, they stay the same. Oh, I know the piece I'm actually missing right now. I need to calculate the current rotation because where you are impacts where you are, where the waypoint is. Where you currently are impacts this. West. Actually, it might be easier to do it. Okay. I feel like I constantly need a reference chart of what the standard rotations are. So 0 is plus plus. Positive negative is 270. Now this is going to be easier to read flat. West 0. South less than 0. In that case, where are we? We're talking about 90. Else if east west less than 0. Oh wait, no, this needs to be reversed. Less than, greater than, south, greater than 0. Okay. Then we go 180. Zero and north south less than 0. We're at 270. Okay. I think we're making progress now. And let's make a little method that's going to determine what our x and y are after we rotate. Yeah, I think this is. We don't care about old rotation. West, south. What this can do is we can do a rotation, current rotation, west, south. Current rotation. Actually, current direction is what we're. Current direction. Typo there. Perfect. Okay. Direction. Rotate. Direction. Rotation. Okay, that's perfect. If direction, we're going to do this absolute value thing. And also, let's actually throw like an. I'm not really counting when the direction is exactly 0. So we'll throw a little exception there, so we don't just end up like with a weird result. Okay, so direction. So when this is exactly 180, we stay the same. So let's actually. West. Just going to swap these values now. West. Because if the rotation's 90, actually we can just say 90, right? Well, sometimes it's not 90 though, right? Sometimes. It's exactly 180, we know. I guess it's actually like 0 to 180 is 180, 90 to 270 is 180 as well. 0 to 90 is where we want to hit. 0 to 270 is where we want to hit. 90 to 180 is where we want to hit. Okay, I think we're doing by doing not 180 that. Doing a 180 rotation, we keep the numbers the same. Odd 90 means swap.
because those are the only options. You can rotate because we're constraining the limit to somewhere between 0 and 270 because we're always rotating by 90 degrees. We know that the only options of offsets could be 90, 270, or 180. Okay, I think that makes sense. Okay, so now let's care about the polarity of these. Um, so we can actually, I guess, just do a little case statement, a little if statement for now. Do if the new direction is 0, uh, north south equals south abs, east west abs. It's always in that quadrant. If direction 90 west abs. South equals north. Oh wait, no, this is east west times -1. Direction 180. We want both these to be negative. -70. East-west stays positive. North-south becomes negative. Okay. And then we just want to return east-west, south. Okay, so we're wrapping up all the rotate and everything in here, so we just need the offset now in these L and R's. And rotate's taking care of the overflow and underflow. Perfect. Okay, so L and R just got a lot simpler. If I could remember the name of the function that called it. Position after rotation. For L, waypoint east, west, waypoint north, south equals waypoint east, west, waypoint south. I think that's a way to format that. And rotation is actually value. If we're going left, it's positive. Okay, I think now we're getting somewhere. Fill up all these lines. We're going to do the same thing here, except we're going to make the value negative because we're going in the other direction. We're going to make the rotation direction. And let me just make sure, did am I raising? Okay, I want to raise here in case if for some reason our assumptions aren't correct, and there's like a weird angle here that we weren't accounting for. Okay. This might work. Let's move back to our sample input. Which fooled us last time by saying that we were correct when we were actually terribly, terribly wrong. I think this is everything we need here. I feel really good about F still. North, south, east, west, those all look really good. And we spent a lot of time on L and R, so I feel kind of good about where they are now. Let's see what sort of typos we have here. 286. Okay, so we still have a good value here. It still says 286. Okay, let's run our input. And let's see what that's not what we want. Okay, so we need to actually treat exact 0 here. Okay, so let's have east, north, south. If it's 0, 0, we're going to treat it as east, I guess. I think that's reasonable. Before we do that, actually, I'm curious what the values for east, west, north, south actually were. Just from my own curiosity, really. That's not exactly 0 here. Glad I checked that, because that's actually not the issue. So, we have positive, positive, negative, positive. Oh, the 180 is wrong. Either the 90 or the 180, because those are identical logic there, so we're missing a case. So let's... $180 is supposed to be negative, negative. Let's see what this looks like. Oh, okay. So we didn't need to handle exact 0. I'm glad I added that extra debugging in, because that could have gotten kind of weird. So now we have a new value. We know what our old value was? Okay, 62,000. That was wrong. Terribly wrong. It said it was too high, and now we have a lower number. So let's see if we get another star. Okay, we did it. Did it. Fantastic. Okay. I don't know if that was actually more hard, or I just didn't really understand what the problem was asking for, which is kind of unfortunate. But you know what? It was kind of interesting to deal with, right? I had fun. I hope you guys all did too. I think now that we've completed the problem, I think we're done for today. We'll be back tomorrow. Feel free to drop a follow, join the Discord down in the links, and it'll give you a notification when we go online. Follow the Twitter, where I will never post anything ever, because that's not what I do. There's also a link to the GitHub if you want to follow along. I'll actually add these up there right now. Day 12. And special thanks to Glenn for giving me a little nudge in the right direction and helping me kind of think through this and make sure I wasn't going down terrible, terrible routes. Cool. That's everything for today. So thank you so much for hanging out, and we'll be back tomorrow in the afternoon to do do day 13, lucky 13, and hopefully it'll be a good one. All right. Bye, everyone.